Right, in the previous video, we looked at kinetic energy, and in another video, we also looked at gravitational potential energy. Okay, this video, the one that you're watching now, will put these two energies together into a concept known as the conservation of energy. Okay, so let's start with a review of kinetic energy. Okay, kinetic energy. And if you remember, this is the energy that moving objects have. Okay, the energy of moving objects. Okay, so when you're moving, you have a velocity, you have speed, you have what we call kinetic energy. Okay, we denote kinetic energy by Ke, and we say that it's equal to 1/2 mv squared. Okay, m here is the mass of your object, and v is the speed or the velocity of your object. Okay, and the units of kinetic energy are joules. Okay, so that's kinetic energy. The other energy that we looked at, okay, was gravitational potential energy. Right? Gravitational, from the name gravity, right, force of gravity, potential energy. Okay, we say potential. In physics, we mean stored. Okay, it has the potential. It has the ability to do something. And it has the ability to perform work. Okay, it's stored energy. And this gravitational potential energy is energy stored. Okay, energy stored, right, by objects above a reference position. Okay, it has to do with how high, right, this energy has to do with how high an object is from a reference. Okay, so we called GPE, our gravitational potential energy, and we said that was equal to mgh. Okay, m here again is the mass of that object. G is the gravitational field strength. Okay, the value 9.8 meters per second squared. That's acceleration due to gravity. Right, they're equivalent numerical values, equivalent concepts. Yeah, gravitational field strength, and this is the so-called height. Okay, say height. Usually, we're measuring it from the ground. Okay, so this GPE, because it's also an energy, is also measured in joules. Okay, so the previous two videos that I asked you to watch looked at kinetic energy, some calculations, gravitational potential energy, and also some calculations. Okay, now I'd like you to consider the following. Here is our object. It has a mass small m, and its weight is mg. Okay, so that's the weight. Notice that I'm drawing that arrow. The tail of that arrow resides in the object. Now, this object with mass m is a certain height from a reference position in the ground. Okay, it's height h. Okay, now at the top here, it's not moving yet. Okay, you're yet to drop this object. You're going to drop this object from rest. So at the top, the velocity is 0. Right, not moving. Because the velocity is 0, then that means the kinetic energy, 1/2 mv squared, must also be 0. Okay, so why am I doing that? It should be 0. It should be 0. Now, the GPE is mgh. Okay, m is the mass of that object, g, that's the gravitational field strength, and h is the height. Okay, when this object falls, right, it's going to fall towards the ground and eventually end up here. Okay, when the object's at the ground, then the GPE is now 0, right, because h is 0. And the moment that the object hits the ground, the kinetic energy is 1/2 mv squared. Where v here, this v here is the speed on impact. Okay, it's how fast the object is moving when it hits the ground. Okay, we're not talking about bouncing here. Even if the object bounces, right, it's the speed first time that the object hits the ground. Okay, and when the object is on the ground, GPE is 0. Okay, so have a look at this. At the top, my GPE is mgh. At the bottom, my GPE is 0. It looks like the GPE was destroyed. Well, that can't be. Okay, that can't be because energy cannot be destroyed. Not be destroyed. At the same time, if you look at kinetic energy at the top, kinetic energy here at the bottom, it looks like we've created kinetic energy, right? So from 0, it becomes a non-zero value. Okay, it looks like we created energy, kinetic in particular. That can't be true, right? That can't be true because not only can energy not be destroyed, it can also be not created. Okay, so energy cannot be destroyed or created. Well, what's happening here? You cannot make energy, then you cannot destroy energy. What's explaining these values? Well, to explain that, maybe let's consider an intermediate position. Okay, somewhere where the ball is here. Okay, I'm just going to draw the ball here. At this location, right, the kinetic energy is not 0. Oh, that's very hard to read, isn't it? Maybe let's look at pink. Right, the kinetic energy is not 0. Okay, but it's not equal to 1/2 mv squared. Okay, because when this object drops, it's going to accelerate. Its velocity will increase. So that means the kinetic energy at this location is greater than the kinetic energy at the top. At the same time, the kinetic energy at this location will be smaller than the kinetic energy when the object hits the ground. Okay? At the same time, GPE is not mgh. Okay? Because the height now is lower. Right? I have that height now. So that means the mgh is lower. Right? So what's happening here? What's happening here is that my mgh is turning into my 1/2 mv squared. Right? That's right. My gravitational potential energy is being converted to a kinetic energy. Okay? So not only can energy not be created or destroyed, energy, however, can be converted. It can be converted from one form to another. One form to another. Okay? In this case, from gravitational potential energy to kinetic energy. Okay, these two statements, very, very, very important in physics. These two statements summarize what's known as the law of the conservation of energy. Okay, conservation, not conversation, conservation of energy. Okay, what does the conservation of energy mean? Well, you cannot make energy, you cannot destroy energy, you can only convert energy from one form to another. Okay, that's the law, conservation of energy. Okay, let's look at a couple of examples. Let's consider the first case when we're dropping a ball. Drop a ball. From a height. Okay, so here is a ball. Okay, Here is my weight. Let's say that my height, just for the sake of argument, let's say it's just 5 meters. Okay, 5 meters from the ground. Okay, so at the top. Okay, so let m be 2 kg. Okay, be 2 kg. So at the bottom here, my GPE is 0, and my KE is 1/2 mv squared. At the top, my KE is 1/2, and sorry, my KE is 0 because it's not moving, right? And my GPE is, let's write it this way, and my GPE is mgh. Okay, so these two statements summarize what happens before the object falls, and these two statements summarize what happens after the object falls. So my object here ends up there. Okay, so remember, the law of conservation of energy says energy cannot be created or destroyed, it's just converted from one form to another. In particular, the energy, right, before is equal to the energy after, right? But let's explain what that E is. Okay, that E is just the sum of the KE plus the GPE. Okay, this sum here is known as the total mechanical energy. Mechanical energy. So what we are saying essentially is the total mechanical energy before the object falls is equal to the total mechanical energy, right, after the object has fallen. Okay, so let's look at the left-hand side. What's the total mechanical energy of the object before it falls? Well, it's the kinetic energy before the object falls, that's 0, right, plus the gravitational potential energy of the object before it falls, mgh. Okay, so that's the left-hand side. That's equal to right-hand side, which is the total mechanical energy of the object after the object falls. Okay, what's that? Well, it's kinetic energy, 1/2 mv squared, plus the gravitational potential energy, right, when the object has fallen. All right, the zeros you see will cancel out. Okay, we can cancel out zeros. Okay. And it also looks like the masses will cancel out. Okay, all right, let's do some algebra. We can multiply both sides by 2. 2gh is v squared. Okay, what's the purpose of this exercise? The purpose of this exercise is to find out how fast, okay, how fast does the object fall, right? How fast does it hit the floor? Okay, and it looks like we have an equation here. Okay, so we now substitute, because I know what g is. It's 9.8 meters per second squared. My h is 5 meters. This is v squared. Okay, so let's see. This is about 99 or about 98, right? V squared is about 90. Is it 99? 99, maybe it's about 98. Okay, so that means v is about 9 point. I think it's about 9.8, right? 9.8, 9.9 meters per second.